Professor Anthony Aguirre has been grappling with the sticky matter of the origins of our universe. And his attempts to find answers lead to a completely different sort of multiverse.
This picture is actually something pretty amazing. It's a picture of our observable universe just a couple of 100,000 years after what we call the Big Bang. And it's a picture that's been taken in what's called the cosmic microwave background radiation. This is radiation that's come to us to telescopes like this one and many others since. And it gives us an actual image of what the state of the universe was like at incredibly early times.
The image, which depicts both the edge of the universe as well as the earliest light we can see, revealed that all the matter in the universe, all the stars and all the galaxies were very evenly distributed. It suggested something happened to make it that way. And that something is a process called inflation.
The theory of inflation is that early on the universe didn't just expand, but it expanded exponentially, meaning it doubled in size over and over and over again in a very small fraction of a second. Now, what this did was it took a pattern of variations in the density of the universe, the same pattern we see now, and it took it from a tiny size and stretched it over the entire observable universe.
According to inflation, while our universe was just a hot ball of fire, the very fabric of space inflated. It was so rapid that the uniformity of the baby universe was preserved. But for Anthony, inflation was more than just a method of expansion. It was a driving force that created our universe in the first place. And if it could happen once, there was nothing to stop it happening again, and again, and again. This is eternal inflation.
So inflation was a little bit like a genie that you let out of a bottle. You open the bottle and you ask the genie, make me a universe. And the genie does a spectacular job of it. But then the genie says, well, I'm going to make another universe. Well, wait a minute, I just wanted one. No, I'm going to make 10 more universes. No, I just wanted one. I'm going to make an infinite number of universes. And that's what we're talking about with eternal inflation. Once the genie gets out of the bottle, it just never stops.
So, asking two simple questions have for different reasons led to the same conclusion. What we see when we look up at the night sky is just a tiny fraction of the story of our existence. However, things get even stranger when you consider the hardest question of all. How does the universe actually work? Professor Seth Lloyd resides in the totally weird world of quantum physics, where nothing is quite as it seems. And where things can be in two places at the same time.
The important thing to remember about quantum mechanics is that it's weird. Silly, silly, stop, 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 stop. I don't understand that, but I console myself with the fact that nobody understands it.
It was from an attempt to make sense of this strange quantum world that the idea of many universes was born. It all began in the 1950s, when maverick genius Hugh Everett tried to explain the weird phenomena at the heart of the now infamous double-slit experiment, where electrons can be waves and particles at the same time.
The famous double-slit experiment in quantum mechanics, where a beam of electrons go through space and then they go through two slits. Now, the wave goes through both slits at once, and on the far side, the wave interferes with itself and then hits a screen and makes an interference pattern Now you might say, oh, come on, like there's lots of electrons, like, oh, so the electrons have waves, big deal. But in fact, if you attenuate this beam of electrons, so there's only one electron going through at a time, you still see this interference pattern, even though there's only one electron. So the wave for one electron goes through both slits at once, ends up on the screen, interferes, and makes this pattern.
In the experiment, when single electrons are fired through two slits, you'd expect them to create two vertical stripes on the screen behind. But in fact, they mysteriously create three. The pattern is only possible if the individual electrons behave as waves, passing through both slits at the same time. It's completely counterintuitive and simply doesn't make sense. The trouble is, it seems to be true. It's a problem that even the finest minds in physics have battled with.
Actually, there's a lot of resistance to quantum mechanics. The most famous resistor of quantum mechanics was Einstein, who famously got his Nobel Prize for work he did on quantum mechanics. But he nonetheless didn't like it. God doesn't play dice, he said. But he was wrong. Suck it up, Albert.
And like Einstein, Hugh Everett was also unhappy with the existing interpretation of the experiment. And so he came up with a radical new theory.
In the mid-20th century, Hugh Everett came up with what he originally called the many worlds theory of quantum mechanics. So the idea here is that when you make a measurement of a particle that's here and there at the same time, and you find the particle over here, then there's a U which finds the particle over here in this world, but at the same time, there's another world over there where another U has found the particle over there. And both of these worlds are equally real.
Hugh Everett's big idea was that at the point when the particle can go through one slit or the other, the universe literally splits in two. The particle goes through both slits at once, but it does so in two separate universes. It was both ingenious and terrifying, and at the time, it seemed totally bonkers.
Despite the fact that now really is a very widely accepted theory of quantum mechanics, at the time it got a very frosty reception, and he couldn't get a position in physics.
Everett's extreme idea set him at loggerheads with the establishment, and sadly he died before ever receiving the recognition he deserved. But in recent years, there's been a remarkable turnaround. Everett's idea of many universes, bizarre and counterintuitive as it seems, is now considered by many to be the only way to explain how the world really works.
Everybody's intuition about quantum mechanics is wrong. And so if you're going to demand that your intuition be right, you're just going to be unhappy. On the other hand, if you can just accept that your intuition is wrong, you know, grab your quantum surfboard and surf that quantum wave, then life can be good.
In spite of the weight of evidence now pointing towards the multiverse, until very recently anyone dabbling in this field risked career suicide.
I couldn't get a job to save my life.
When I was a grad student, I used to secretly print out my multiverse-related papers when my advisor was far from the laser printer, and I didn't even show these papers to him until after he'd signed my dissertation, because it was considered mostly science fiction and speculation back then.
But what are the other... This job at MIT was the only job I was ever interviewed for. I was on the verge of having to drive a taxi cab.
Three entirely different questions have all led to the same conclusion. The multiverse is now impossible to ignore. Beyond the realm of our most powerful telescopes, Max believes infinite universes to be a mathematical certainty. He thinks the universe simply cannot end. While for Anthony, the quest to understand our origins provides a tantalizing glimpse of a time before, when inflation brought countless other universes into existence.